So today I'm gonna be explaining this important paper with the title Just Jump, Dynamic Neighborhood Aggregation in Graph Neural Networks. This a clear paper in 2019. We proposed dynamic neighborhood aggregation procedure guided by multi-head attention for representation learning in graphs, in contrast to current graph neural networks which follows a simple neighborhood aggregation scheme. Our DNA procedure allows for a selective node adaptive aggregation of neighboring embeddings of potentially different locality. So to avoid overfitting, we propose to control the channel-wise connections between input and output by making use of grouped linear projections. In a number of transductive node classification experiments, we demonstrate the effectiveness of our approach. So GNNs operate over graph structured data and iteratively update node features by aggregating localized information. But this jumping knowledge network enables deeper GNNs by introducing layer-wise jump connections and selective aggregations to leverage node adaptive neighborhood ranges. So the final output could be either summation, pooling, or concatenation. Weight the values of a set of key-value pairs according to a given query by computing scale dot product between key query pairs. Of course, this has quadratic complexity because of this part, and of course there are linear complexity versions of this normal attention, but this part is challenging, still quadratic complexity. And then they do grouped operations, control the channel-wise connections between an input and an output to reduce the number of parameters by G, the number of groups. So we propose to allow jumps to earlier knowledge immediately while aggregating information from neighboring nodes. This results in a highly dynamic receptive field in which neighborhood information is potentially gathered from representations of differing locality. Each node's representation controls its own spread out. So we allow each node neighborhood pair to attend to all its former representations. So we replace the single attention module by multi-head attention with a user-defined number of heads while maintaining the same number of parameters. Due to being already projected, we do not transform incoming node embeddings. We incorporate an additional parameter to the softmax distribution of the attention module to allow the model to refuse the aggregation of individual neighboring embedding in order to preserve fine-grained details. So given the current node representation is a query, a node adaptive embedding gets computed for all neighbors based on their former representations, either preserving the current state, previous state, or no state at all. In addition, self-attention is applied to retain central node information. So they did experiments on these datasets like Cora, Sightseer, PubMed, and they compared different types of models, some based on GCN, graph attention, and the proposed method.